This is the lesson on equations of exponential functions. So we need to start with some important exponent rules to remember. So the first one, you have a negative exponent. It doesn't mean it's a small number. A to the negative n is 1 over a to the n. That negative exponent says we're going to flip whatever's here, a over 1, which would be 1 over a, and make that negative exponent positive. So for example, 3 to the negative 2 is kind of a cool way of writing 1 over 3 squared, which is 1/9. So fractional numbers can often be written with negative exponents. Same thing here, if we have 1 over a to the negative n, well, we're going to flip that 1 over a, it becomes a to the n. So if we have 1/3 to the negative 4, that's actually 3 to the 4th, or 81. Second rule, any number to the 0 power is 1. A to the 0 equals 1. So 324 to the 0 is 1. Third rule, the nth root of a. If you have a radical, you can always take a radical and rewrite it as an exponent. So there's an understood, I'm going to expand this. So if I had the nth root of a to the m, there's a 1 here. The nth root of a to the m is a to the m over n. So the exponent that belongs to the a goes into the numerator and the index goes into the denominator. So that's what happened here. The nth root of a to the 1 is a to the 1 over n. So if you had the cube root of x squared, that's the same as x to the 2/3. Next, non-translated exponential functions. So this is the way you can write an exponential function. F of x equals a times b to the x, and there's not a plus c yet because we're just talking about non-translated exponential functions. This is a review, but this is new. A is called the initial value, or the y-intercept. Okay, and the reason is because if we want to find the y-intercept, remember, to find a y-intercept, you always set x equal to 0. That's how you find a y-intercept, and that won't change. You have to memorize that. So if I come over here and change f of x to y like we're like to, and I put 0 in for x, then you have to remember PEMDAS. You can't multiply this a times b first. You have to do the exponent, and we know any number, don't need to know what that b is, but any number to the 0 power is 1. So you get y equals a. So when x is 0, y is a. And that's why this a is the y-intercept. In a word problem, I'll call it the initial value, because a lot of times we'll let x be time, and at 0 seconds, it's whatever you started with, whatever amount you started with. So that's why I call it the initial value a lot of times. B is, as you should know, the base. And the base is always going to be positive. So this base is always going to be either between 0 and 1. That would give you decay, and that would look like this. Or it's going to be greater than 1, growing, and that would be like this. True or false? F of x equals 2 times 3 to the x is equivalent to f of x equals 6 to the x. That is false, because you cannot multiply these two together. Even though you don't know what this is, if you put a number in, you have to square it first and then multiply. So you cannot do this or it'll mess your problem up. You have to leave the a and the b value. You never ever multiply those a and b values together before you get x. So here's what I said just now. This is growth. This is when b is greater than 1. This is decay. This is when b is between 0 and 1. And b won't ever equal 1, because if it did, it would be very boring, because 1 to any power is just 1, and the function wouldn't curve or anything. Okay, so a quick translations review. It says graph the following in the Desmos to verify. So we'll do the first one with the graph first, and then we'll see if we can remember what happens after. So if I graph y equals 3 to the x, we have growth because B, A by the way is 1, there's an understood 1 right here. B is 3, so that's why it's growth, and it's not translated, so the domain is going to be 0 to, excuse me, so the domain is going to be all real numbers, because exponential functions, your domain is always all real numbers, and your range is going to be 0 to infinity, but there's a horizontal asymptote. As x gets really small, y is going to head to 0. So the range is 0 to infinity, and the horizontal asymptote is y equals 0. Okay, the second one, let's see if you can do this by yourself. So just think about it. Y equals 1/3 to the x plus 2. Okay, that's going to be decay. So that graph is going to look like that. But let's think about what's going on here. What does that plus 2 do? Well, that's going to shift it up too. So it usually hugs the x-axis. Well, this time it's going to hug 2 up from that x-axis like that. And so this is decay, and so it's going to look like this. Okay, let's check it in Desmos. So parentheses 1/3 to, let's delete all that. Parentheses 1/3 to the x power. And see, before I translate it, it's down here, horizontal asymptote y equals 0. But then I add the plus 2, and then you can see your horizontal asymptote y equals 2. So the domain, again, is all real numbers. Exponential functions always have a domain of all real numbers. Horizontal asymptote would be y equals 2 because the range starts at 2, not including 2, but then going to infinity. And by the way, this a value again is 1. It has an a value of 1, so the y-intercept would be 0, 1. But it wouldn't because it's being translated. So add 2 to that y-intercept, so the y-intercept really would be 0, 3. So you can see in this graph, here is the y-intercept. Next one, y equals 2 times 3 to the x minus 5. Is this going to be growth or decay? That's going to be growth. What's the graph going to look like? Well, first let's think about that minus 5. That minus 5 is going to shift it down 5. And its growth, a this time is 2. What would be the y-intercept? 0, 2? No, because it got shifted down 5, so everything got shifted down 5. So the y-intercept would be 0, negative 3. What does this 2 do? Remember, when you multiply a number times the outside of the parent function, it gets this is going to be a vertical stretch. So I'm just going to graph the negative 3, and then I'm going to make it hug its growth. I'm going to make it hug this horizontal asymptote, and then I'm going to make it get bigger a lot faster. So let's see what happens when we graph this. So we have 2. We can put parentheses like that if you want, or you can put the actual times to the x power minus 5. We can see that we do have a y-intercept of negative 3, and we do have a horizontal asymptote of y equals negative 5. And if I just compare this function without the 2, you'll see that the red one got stretched. You can see that now. So that 2 stretched it. Okay, so back to this. The domain again is all real numbers because you can put anything you want in for an exponent. The horizontal asymptote is just going to be whatever's there. So that's y equals -5. And the range, if that's your boundary down there, then your range is -5 to infinity. So therefore, when a is greater than 0 and h of x is equal to, this is the translated form now, when you have plus c added, what's going to happen is it's either going to be growth or decay depending on this b, but the domain will always be all real numbers for all exponential functions. The horizontal asymptote is going to be y equals c, and the range will be from c to infinity. So you can generalize what we just saw there. Next, I got these problems from the lab manual, so you can go there if you want to. Writing equations of exponential functions. And it says find the exponential function f of x equals y equals a b to the x plus c. And the way that I teach it is I teach you to learn something called CAB, the CAB method. And that just means this is the order of the letters that you're going to find. Now these letters may change. You have to be aware of that. So you need to know what c means. C is this plus c, the number that's added out here. Then you want to find the initial value, then you want to find the base. So if you see something like f of x equals d e to the x plus f, I would just say, let me rewrite it this way. Just rewrite it, and then you can use the CAB method. Okay. So if you're given a graph, you'll be given an exponential function, and you'll be given a horizontal asymptote, and you'll be given a y-intercept, and you'll be given some other point. Okay? So step 1 is you have to find c. Now what we just learned up there is that c is always the horizontal asymptote. So we come and look at the graph and you say, okay, well the horizontal asymptote, it's hard to see, but since this is 0, -3, this must be a -2. So the horizontal asymptote is y equals -2. So that means that c equals -2. Okay, next step is find a. Now remember, a comes from the y-intercept. A is the y-intercept, so what you're going to do is you're going to use the y-intercept. And this is why you have to do this step next. So this is x and this is y, and we're going to write down y equals a b to the x plus c. We're going to plug in the things we know. So y is -3/2. A we don't know, b we don't know, which is normally a problem to not know two things, but x is 0 and then c is -2. Okay, so we're going to solve this. Well, we can get rid of this -2 by adding 2. So 3/2 minus 1/2 is 2 minus 1/2 is 1/2. You can use your calculator. If you get stuck on the arithmetic, just use this. Negative, get rid of that out of that. So -3/2 plus 2. This should not be the reason you miss an answer. Hit the squiggle and you get 1/2. And we definitely prefer fractions, so don't put the decimal. Alright, now the trick here is b to the 0, remember, is 1. B to the 0 equals 1. So that just leaves us with a. So a is 1/2. So we have c, we have a, now we need to find b. It's usually the hardest algebra. So what we're going to do to find b is just going to pick another point, and the point that they've given us is 2 5/2. You might have to pick it yourself. Okay, So use this again, y equals ab to the x plus c, and we know y is 5 halves. A we now know is 1 half. B to the x, this is 2, and then c was minus 2. So this is the toughest algebra. You want to get b by itself. The first thing is squared, then it's multiplied, then it's subtracted. So you always want to undo the opposite of the pendus, so we're going to add 2 to both sides. Alright, and I'm going to demonstrate that you don't want the arithmetic to mess with you. So 5 over 2 plus 2, hit the squiggle, you get 9 over 2. So 9 over 2 equals 1 half b squared. Okay, we've mentioned this before. To get rid of a fraction that's being multiplied, you can multiply both sides by the reciprocal of that fraction. And this is why I'm demonstrating why you like improper fractions better. At least I do. Because 2 times 9 over 2 is the same as 2 over 1 times 9 over 2. And this 2 and this 2, they are going to cross cancel. And you're left with just 9. Didn't have to use a calculator. Alright, the next step is we're going to take the square root, which is usually going to mean that we're doing plus or minus, but since we know b is positive, it's just going to be 3. And then the last step is to rewrite the function f of x. This is the equation f of x, a, which is 1 half, times b, which is 3, to the x minus 2. And you have your x back and your output, your input and your output. So that's how you write equations of exponential functions. Okay, so let's try one more. This is number 5 in the lab manual, and this is an interesting one. This does not look like our typical exponential. This exponential got flipped over and the x-axis, so that means that there's a negative involved in the a. Okay, you can use that to check your work. You should kind of cross-check with the different concepts that you've learned. Okay, so again, we're going to start. You have to have that memorized, and we're going to use the CAD method. And that means we're going to find c first. So step 1 is to figure out what the horizontal asymptote is, and horizontal asymptote, since that's 8/9, it's really hard to see, but that's y equals 1. So step 1, c is 1, since horizontal asymptote is y equals 1. Step 2, we need to find find a for CAD, and we're going to use the y-intercept because that's what a is, and because the y-intercept has a 0 as an x coordinate, and that's the key. So if I write down y equals a b to the x plus c, I'm going to plug in what I know. So I'm letting y be 8/9. A I don't know, b I don't know, x I'm going to let be 0, and then c we just found it's 1. So I'm going to subtract 1. 8/9 minus 9/9 is -1/9 equals a. B to the 0 is 1. So there is our a. And as I suspected, our a value is negative because this is a strange looking exponential function. It's been flipped. And a negative multiplied to the function will flip it. Okay, next thing, c. We found c, we found a. Step 3, you need to find b. Okay, so b, we're going to use y equals a b to the x plus c, and we're going to pick another point. So the point that you were given here is 5 -7/2. So that's our x and that's our y. So we'll put -7/2 in for y. A is -1/9. B we don't know. X is the 5, and then c is 1. Okay, so we got complicated algebra to do, but let the algebra talk to you. Just remember what it says, and we'll let the calculator deal with the arithmetic. So you should know, alright, I got to subtract this 1 out first. Alright, so I'm going to put in -7 divided by 2 minus 1. And I prefer the fraction, so that's negative 9/2. If you hit the little squiggle, that'll turn it to a fraction. So that's negative 9/2 equals negative 1/9 b to the 5th. Do you know the next algebra step? Yeah, to get rid of multiplication by a fraction, you can multiply by the reciprocal. So the reciprocal of negative 1/9 is negative 9 over 1. And this time things don't cancel. But we can just multiply straight across. Negative 9 times negative 9 is 81. 1 times 2 is 2. Okay, now we have a bit of new algebra to do. How do you get rid of this 5 as an exponent? You can do this two ways. I'll do it both ways. Your objective is to get b by itself. You want to get rid of the 5. You can't divide by 5. You can't subtract the 5. You have to understand exponents to know how to get rid of the 5. My preferred method is to raise both sides by the same power. You can do that. That is legal. What could I raise this b to the 5th to make that 5 become an understood 1? Well, I could raise it to the 1/5 power, that rational exponent that I told you about at the beginning. Because 5 times 1/5 is 1. So you can raise it to the 1/5 power. Whenever you do to one side, do the other. So this is going to become b to the 1, or just b, and then let's figure out what that is. 81 over 2 to the 1/5 power. So parentheses, 81 divided by 2. Use this exponent button to the 1/5 power. And it's going to come out pretty nasty, and it's not going to change. It's an irrational number. So this time you're just going to have to round, and I like to round to the hundredths place. So this hundredths place is the second. Actually, with exponents, it's traditional to round it to 4 decimal places. So 1, 2, 3, 4. That's the 4th decimal place. And if the number after this is 5 or greater, you're going to round up. So this would round to 2.0965. There's your b. So step 4, we'll write the equation. Y equals a. A is negative 1/9 times b, which is 2.0965 to the x power plus 1. So that's your final answer. And you can check your work to see this. If you unflipped it, let's see, move this down so you can see. If you unflipped it, it would be growth. So it makes sense that that a is negative because of the flip, and that b is greater than 1. And your y-intercept was y equals 1. So that checks out. Okay, and I told you I would show you the other way to get rid of this. If you want to get rid of this 5, the other way you could do it is you could take the 5th root of b to the 5th. That's legal. 5th root of b to the 5th is just b. And then whatever you do on one side, you're going to do to the other. So I'll take the 5th root of 81 over 2. And so the 5th root of 81 over 2 is, you have to look in blue where you see this little square there. And so you have to hit that first. So the 5th root, the 5 is the index. Then I'm going to hit this. And then type in 81 over 2. And it gives you the same answer. Okay, so you have some of these to practice in the lab manual. I've done 1 and 5. You do the rest of them and just keep practicing and check the key to make sure that you know what you're doing. Okay, and I'm going to add one more example because we have not done a decay exponential function yet, and some pretty tough algebra happens, so I'm going to go and do this very quickly. Remember, we start out with y equals ab the x plus c. We find c. This is 0, 2, so I wanted that to be y equals 1, so c is 1. Then we want to find a using the y-intercept. So that's this, that's x, that's y. So 2 equals a, b to the 0 plus 1, b to the 0 is 1, so 1 is equal to a. Okay, so we have c equals 1, a equals 1. All right, the b is always the harder algebra. So remember, to find b, you want to pick a point, and the point given is -3, 4.5. I would immediately change that to 9/2, but you probably won't want to. Anyway, we're going to plug in into y equals a, b, the x plus c, and we're going to put 4.5 in for y, and a is 1, and b we're looking for. So I'm just going to put b, 1 times b. Well, I won't do that because that's a bad habit. 1 times b to the -3 plus 1. Okay, so I'm glad that I did that. I almost did a mistake. You can't do 1 times b because you have to do the exponent first. So if this wasn't 1 and you did 2 times b, that would be bad. So that was a bad move by Miss Mills. So we want to leave that 1 there. Okay, so then how would you get b by itself? Well, we would subtract 1. 3.5 equals 1 times b to the -3. Now, if that wasn't a 1, you would have to divide that next. So I'm going to go ahead and demonstrate. I'm just going to go through it because you cannot combine those two. So anyway, you get 3.5 equals b to the -3. So that's where the 1 went. It didn't get multiplied to the b, it got divided out. That's what I wanted to talk to you about, because people always ask in a seated class how you do this one. So you have to, I've shown you 2 ways to do this. I like to use rational exponents. So you have to remember that you can raise this to any power you want as long as you raise that to that power. So if I want to get a positive 1 right here, I'm just going to raise it to the reciprocal of -3, which would be -1/3 power. Because I have a powerful calculator, that'll do that for me. So parentheses 3.5 raised to the -1/3 power gives me 0.6586, because the 3 is not going to make that 6 go up. So there's your b. So I think that's easier. So y equals a, which we found to be 1, parentheses b, which we found to be 0.6586, which is less than 1, so it's not a surprise since this is a decay function, to the x power plus 1. Okay, so let's go back to this key step right here, and I'll show you the other way students might decide to solve it. You still need to divide by 1 and get 3.5b to the -3. Some people, this is new, raising stuff to the reciprocal power is new, so some people like to do this. You can use negative exponent rule right here, but remember, you're not changing the left side. The negative exponent rule says flip me and make me positive. So you can make b to the -3 1 over b cubed and then cross multiply. So if you cross multiply, you get 3.5b cubed equals 1. And then you would divide by 3.5, and then you have to figure out how to get rid of this cube root, and most people might try to take the cube root of both sides, and that would work. I didn't bother to pick up my calculator yet. I'm going to pick up my calculator now. So you're going to have to remember to put this 3 down first, and then hit this square with the radical, so second x to the square, and then type in 1 divided by 3.5, and you should get the same answer. 0.6586, got the same thing. So practice those. You've now got one that's decay, and so this negative exponent will appear when you have a decay. You have to figure out which method you're going to want to use to get b by itself.